Okay, here we go. We're looking at part 2 of textbook section 4.1, where we're going to study something called arc length. And basically we're going to be solving problems using a formula. The formula is theta equals A over R, and this formula can be found on your formula sheet that you would get for any exams, including the diploma exam, if you so choose to write it. I kind of anticipated that we would be learning this way, so when I made the remainder of the notes for this course, I kind of pared them down a bit. Normally I would explain to you where this formula comes from, but in terms of being able to do the math, it's not important. So this formula relates an angle to the arc length and the radius. Now, arc length is the distance around the outer edge of a circle. And I hope it's obvious that there must be some kind of relationship. Looking at this diagram, I mean, there has to be some kind of relationship between how much the angle is, what the radius is, and what this arc length is. Just common sense says if the angle is greater, the arc length will be greater, and if the radius is greater, the arc length will be greater as well. In fact, I will almost always, well, I'm getting better at this, but this formula, when I learned it, it was A equals R theta. And that was, to me, that made more sense because the bigger the radius, the bigger the arc length, and the bigger the angle, the bigger the arc length. But what you have to remember, and this is the equivalent, everybody, of forgetting to factor out B in the first unit. You have to remember that this formula only works when the angle is in radians. And I guarantee you that on exams, many students forget to work in radians. And they will get a wrong answer, obviously. So we're going to just look at a brief lesson here. There's only a couple of examples of using that formula. So to begin with, this says we have a 40 centimeter long pendulum that swings through an arc of 35 centimeters. Now, a pendulum is just some kind of mass hanging on a spring, mass hanging on a string. The mass is usually called a pendulum bob, but that's okay. It doesn't matter what it's called. It swings back and forth. And since the string doesn't change length when the pendulum moves, that arc, although it isn't a full circle, that arc is part of a circle. And we are asked to find the angle through which the pendulum swings in both degrees and radians, most likely on an exam. And we still don't know what's going to happen with exams, but it would be a numerical response question that would say degrees. How many degrees is that? So let's identify the fact that the 40 centimeters is the radius. And the 35 centimeters is the arc length. And we're trying to find the angle. So the angle is the arc length, which is 35 centimeters, divided by the radius, which is 40 centimeters. By the way, these two quantities have to be in the same units. So if one was centimeters and one was meters, you'd want to make sure they're both meters or they're both centimeters. So now we divide that, you get 35 divided by 40. I know that one, that's 0.875, but I will just confirm to make sure. What do we have, 35 over 40? Yeah. So it's 0.875, and that answer is in radians. But we also want the answer in degrees. So we have to convert this to degrees. And it's okay here to have an answer in decimal form. This is the kind of question that you would want probably as a numerical response. So all I'm going to do is set up a ratio. I'm going to say that pi radians over 180 degrees, our friend from the first lesson, equals 0.875 rads, or radians, over x degrees, and we cross multiply. X equals 180 multiplied by 0.875 over pi. When you First cross multiply, you get pi x equals 180 times 0.875. So we have to divide by pi. The rads cancel. I mean, most people don't think about this, but the radians are canceling, and you're left with degrees. So I have 180 multiplied by try that again. I have 180 multiplied by 0.875 and then divided by pi gives about 50.1 degrees. So the answer is 0.875 rads or 50.1 degrees. So these are our two answers. Now, before we go on, I might as well show this to you now. We have time. There is a way on your graphing calculator to convert radians to degrees and degrees to radians, as long as all you care about are decimals. And I'm going to show you how to do this. The first thing that you need to take note of is your calculator has to be in the mode that you want to convert to. So I'm going to go back to before we knew it was 50.1 degrees, and I'm going to say I want to convert 0.875 rads to degrees, which means my calculator has to be in degrees. This is just the rule, and I am in degrees, so I'm okay. So what I want to do here, everybody, from my home screen, is I want to enter 0.875 radians. And when I enter 0.875 radians and hit the enter button, my calculator is going to look at the fact that I entered a radian measure. It's going to look at the fact that my calculator is in degree mode, and it's going to say, oh, he wants to convert that many radians to degrees. So I'm going to put 0.875 down, but now I need to tell the calculator that it's radians, because right now a way to think of it is my calculator is in degree mode. I've entered 0.875 degrees, so I hit enter, it's 0.875 degrees. So I need to slap a radian label on this number. And I don't know how I can do this. Oh, wait, I got it. Well, I'll figure this out for next time. I don't want to change anything. If you look at your calculator, you see the apps key. On my calculator, it is a bluish kind of key. The second operation of that says angle. And if you go to that menu, so I'm going second apps, you see the degree symbol, you see another symbol, which is minutes, don't worry about that, and you see an R, which is radians. So when I choose R, it looks like 0.875 raised to the R, but it's just a radian label. If I hit enter, it gives me 50.1 degrees. So you have to be in the mode you want to convert to. If I wanted to convert, let's say 78 degrees into radians, I would be in radian mode and enter 78 degrees, second app. And since I'm in radian mode, the calculator converts it to radians. Anyway, there's an option for you there. Any questions with example 1? All right. Number 2, a circle of radius 8 centimeters contains a central angle of 132 degrees. What's the arc length? So our formula is theta equals A over R, which, I prefer A equals R theta. So A equals the radius, which is 8 centimeters. I guess we don't really need the units. Multiplied by the angle, but it's a fatal mistake to put 132 in there because the angle has to be in radians. So we take a little detour. 132 degrees equals how many radians? Now, you could certainly use a ratio. Pi rads over 180 equals x rads over 132 and cross multiply. But since I've just shown you how to do this on your graphing calculator, that's what I would be inclined to do. Let's see, I want to convert degrees to radians. So am I in radian mode? Yep. I enter the number of degrees, which is 132, but I need to tell the calculator that that's in degrees. So it's 2.3038 rads. And you're going to get that same number whether you cross multiply and solve this for x, or whether you do what we did on the calculator, 2.3038. And since that 8 is in centimeters, our arc length will be in centimeters. So now we just have to multiply that by 8. And we had 18.4. Any questions with example 2? All right, just one more example. This is from an old diploma exam. So what's happened here is, I think this might be the back window of an SUV or something. It's been splattered with mud, and 1 or 2 swipes of the windshield wiper clear out a clear section. And the windshield wiper has a length of 16 inches, but it's a little deceiving. The actual wiper is only 16 inches long. The distance from the end of the wiper to the pivot point is actually 20 centimeters. And I think this is a lousy diagram. Let me explain to you why it's lousy, I think. You're asked to determine the perimeter of the section that's cleaned out, which means you have to determine the perimeter of this shape that I'm drawing. And I have an issue with this diagram because it was deceptive when it was on the exam. This section in here that's not cleaned, it's covered in mud, isn't the same shade as the mud on the rest of it. And a lot of students found this area or this perimeter instead. Anyway, we want to find the perimeter that I've got highlighted in the bluey green color. So that perimeter actually has 2 lengths of 16 inches each. So this is 16 inches. This is 16 inches. It has a little arc length, which is this, and it has a big arc length, which is this. So we have to find those 2 arc lengths, add them together, and add 16 and 16, which means we're going to be doing 2 arc length calculations. One of the arc length calculations will be A equals the radius times theta. The other arc length calculation will be the radius times theta. Theta is the same in both cases, but the radius is bigger for the bigger arc length. The radius for the bigger arc length is 20. This is the big radius. This is the little radius. I hope you can make that out. So for the small arc length, we're going to have 4 multiplied by the angle. Both of those angles are going to be the same. You need to convert 150 degrees to rads. But 150 degrees is a multiple of 30. And 30 degrees is pi over 6. So 30 degrees equals pi over 6. 150 degrees is 5 30-degree chunks, so it's 5 pi over 6. You could certainly use a ratio like we did in the first lesson, but I don't think it's necessary. Looking at a circle, there is one 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6 is 150 degrees. Okay, so we put 5 pi over 6 in here. Now I'm going to ask us to carry all decimals because this could be a numerical response question. When I calculate that little arc length, I get 20 pi over 6. I'm multiplying across the top, and I'm multiplying across the bottom. When I calculate the large arc length, I get 100 pi over 6. Just double check my math. That's fine. So now what I need to do is add those two arc lengths. Now, we can simplify those. This arc length is 10 pi over 3. 20 over 6 reduces. This is an arc length, it's not an angle. And the big arc length is 50 pi over 3. So what do we need to do? We need to add this, and we need to take 16 for the left side and 16 for the right side. We need to add those four pieces together. Looking up here, just in case you need a little bit of extra guidance, we have to take 10 pi over 3 plus 50 pi over 3 plus 16 plus 16. And that will do it. That will give us the perimeter. What do we get? We get 32. 16 plus 16 is 32. And then here we have, again, this is my way of thinking of this. Although everybody, I think this is important. Although this thing here that I've written is equivalent to this thing here, the bottom one makes more sense mathematically. Rather than saying 10 pi all over 3, think of it as 10 pi over 3. And rather than thinking 50 pi all over 3, think of it as 50 pi over 3. I had a typo there, I wrote the wrong number. See, because then I say to you, well, if I had 50 puppies plus 10 puppies, I would have 60 puppies. That means if I had 50 pi over 3s plus 10 pi over 3s, that gives me 60 pi over 3s. And as luck would have it, 60 over 3 reduces. So we end up with 32 plus 20 pi. And the reason I wanted to keep all of our exact values is you might have been given this question on an exam and told the perimeter is a plus b pi. What are the values of a and b? Well, a is 32, b is 20, so this would be what you would record in the numerical response section of the exam. Anyway, this lesson boils down to a equals r theta. Oh, that's exactly how I worded the question. I wasn't aware that I worded it that way. So it's a pi plus b. Okay, wait a minute. I take back what I said because I said that it was a pi plus b, and down here I said a plus b pi. So we want to compare this to a pi plus b, which is 20 pi plus 32. So a is 20 and b is 32. I hope that didn't confuse you, that I should have actually read the question and saw what I was asking. Anyway, a is 20 and b is 32. So when we answer this question, you would enter 2032. Respectively means in the order listed. So what this lesson boils down to is using the arc length formula, theta equals a over r. I hate to be a fanatic about it, but you have to be in radians. If you're not in radians, this formula just, it's not worth anything. So there's just a couple of questions from this lesson. I said that we're past 2:30, but I said that we would still go 2 hours, so we'll go to 3. You have a little under a half an hour here to do these couple sets of problems, plus to go back and try some of those other problems. I hope everybody got my message that assignment number 1 is available in your shared folders. I believe I said it's due Thursday. You will probably get assignment 2 shortly, within the next day or 2, and it will be due early next week. Again, it only takes a second and it's invaluable information for me. Second lesson, too fast, too slow, just right. Take a second and do that for me, please. And I'm going to mute my mic and get a couple of things done here. And then I will be available for, well, I'm available for help. You need help, let me know. I'm here.